Right, the quadratic equation 4x squared minus 12x plus m equals 0, where m is a positive constant, has two distinct roots. Okay, and then they say show that this quadratic equation here has no real roots. Okay, so let's look at what we've got here with regards to this quadratic equation. So we're told it's got two distinct roots. So first of all, we'll identify what a, b and c are equal to. So remember, in the quadratic, the a is what's in front of the x squared, which is 4. The b is in what's in front of the x, which is minus 12. And the c is this constant then, m. Okay, so we are told it's got two distinct roots. We can say, look, given two distinct, okay, real roots, the discriminant's got to be positive, hasn't it? In other words, b squared minus 4ac has got to be greater than 0. So we can sub in now what we know for a, b and c. So minus 12 for b, take away 4 times 4 for a, and c is m, and that's greater than 0. So that becomes 144 minus, then this becomes 16m, which is greater than 0. Maybe take that minus 16m over, so it becomes a plus 16m, and then divide by 16. So then we get 9 here. Okay, so that's kind of back to front, that inequality. If we read it, m is less than 9. Okay, so we could say m then is less than 9. Okay, so m has got to be less than 9. Quite simple as that, right? Because we're told that this has got two distinct real roots. Okay, so that discriminant holds them where it's greater than 0. So that means that m will be less than 9. Also, as well, note m is positive, right? Constant. So more so, okay, so we can say, you know, moreover, m is actually, well, it's less than 9, but it's also greater than 0 as well. So it's kind of interesting to note that there, yeah, because it's positive. So the second part then, it says show that the quadratic equation 3x squared plus mx plus 7 equals 0 has no real roots. So now we go on to this quadratic here. And the interesting word here, the key word here, is that it says show, doesn't it? Okay, it doesn't say given. It says show that it's got no real roots. So we can actually show this has got no real roots, particularly the fact as well, now we know something about m. We know m is between 0 and 9, yeah? So I can't say, you know, because we want to show it's got no real roots, I can't say b squared minus 4ac is less than 0, okay? But we want to show that, right? We want to essentially show or prove, to show that b squared minus 4ac is less than 0, okay? So we don't start off with this statement, we just work out simply what b squared minus 4ac actually is, okay? So in this case here, remember now, a is equal to 3, b is equal to, in front of the x is m, and c is equal to 7, okay? So let's sub it in, so we'll have m squared, okay? M squared, and then we've got minus 4 times a, which is 3, times c, which is 7. Okay, so that's what b squared minus 4ac is. So this becomes 2 m squared minus, well, if I work that up there, that comes to 84. So we've got to actually show now that this is less than 0. How do we do that? Well, remember, we've got this sort of result for m, yeah? Remember, okay, we can even say that if we want. Remember, m has got to be less than 9, greater than 0, less than 9. Now what I can do is I can adjust this inequality, okay, to get the expression for b squared minus 4ac here. So what I can do, for instance, I could square it to start with, m squared, and if I square it, well, I've got to square the values as well, the inequality values. So that will become 9 squared, which will be 81. And of course 0 then, when I square that, it's just 0, isn't it? 0 squared, 0. So that's m squared, but I want m squared minus 84. So I want an expression for m squared minus 84. So what I need to do then is, because this is m squared, okay, I just need to take away 84 then. So I'm going to take away 84 from both sides of the inequality here. So I end up having minus 84 here, okay, and then this will be minus 3, yeah? So m squared minus 84 is between minus 84 and minus 3. But remember, this is the discriminant, isn't it? So remember, m squared minus 84 is just our discriminant for this inequality. So I can replace, okay, m squared minus 84 with b squared minus 4ac. So we're saying the discriminant, which is m squared minus 84, for this quadratic has got to be between minus 84 and minus 3, based on what we know for m. And in that sense then, we've shown that b squared minus 4ac, well, if it's between those values, it's definitely less than 0. So there's no real roots.